This month, we are speaking to Duane Warren. We've heard he's given several presentations before. He's a great communicator. He works for JLL. I think he'll tell you what he does, but I'm pretty sure what he does is he goes to all these different plants, diagnoses their problems, and fixes them. I think so. He's going to talk about BAS systems. Yeah, there's a lot of problems with BAS systems. They're just a bigger tool. It's like you give someone a hammer. What does that mean? He can build a house? No, it means he can destroy a house if he wanted to. Hammers could do all kinds of things. You need intelligence behind it, just like with the BAS. You need intelligence to install them correctly and also to operate them correctly. And I'm sure that's what Duane's going to tell us. Anyway, I'm going to stop talking, and Duane is going to start talking. Unfortunately, you won't see his image today because of technical difficulties, and I will make it so you don't see mine soon. Okay, Duane, why don't you take over?
Okay, thanks for attending the seminar, and hope I can get some valuable stuff over to you today. The meeting is recorded, and we will be taking the presentation as a file, and they'll be transferring it over to Braxis, and there'll be some backup files, associated files that'll be passed along to you as well. Some of them are going to be pretty valuable, and we'll talk about them in a minute. So this is a process. We're going to be talking today about some things that are going on. So for those of you that don't know me, I'll do a quick little thumbnail sketch. So I've been doing this automation systems, mechanical and electrical systems commissioning, and engineering designing for about 40 years now. In fact, longer than that. It's now 45. So in different parts of the world, Canada, US, Asia, Europe, places like that. And so we picked up some stuff along the way, and we are marching forward into the future here for sure. So we're going to be talking about a collaborative system, method for designing, installing, and commissioning automation systems. This is going to, and for those of you that think that this is a theoretical thing, it is not. We have, JLL, we have completed 2 projects like this. We are in the middle of completing another 5. We have another, at least as far as I know right now, another 8 in the pipeline. And so we are doing it this way. We are committed to doing it this way as a company. So there are 4 primary team members. The owner that defines requirements and makes final decisions, the designer that translates these requirements into specifications, the contractor who delivers a physical system, and it may involve a general contractor or not, that depends, and the commissioning authority. And each of you is going to operate, if you're on this call, if you're any one of those groups, you're going to operate within specific contractual boundaries, but success for this project requires working together as an integrated team. The designer must accept input from the commissioning authority and adapt to vendor capabilities. The BAS contractor must adapt their product to building needs and accept commissioning feedback. And why is this all happening? Well, the industry is fracturing. In some ways, we moved away from things that are sort of state of the art in some cases, and we've moved in and on into systems that were available for installation by most anybody. And they turned into something, we are seeing products that out in the marketplace right now that actually look like they were installed and designed in the 1980s. And this is just not acceptable. It is not acceptable. Buildings are not going to work this way. Owners don't stand for it. No one likes it. And so we just need to all do a better job. Our goal is a system that not only meets contractual requirements, but exceeds performance expectations through that collaborative process. So can I get next slide, please? So this should say owner's project requirements. OPR, comprehensive vision. It's got to establish what success looks like. It's not a single purpose system. The owner has multiple business drivers that must all be addressed simultaneously. Energy cost reduction is obviously important. We're going to see that a lot. We want to make sure that the building energy use is as low as possible, with tenant comfort also being a prime concern for them, because they want space to be leasable. Now the scope becomes a little bit more ambitious, and that involves integration. You're going to be integrating with all building systems, not just HVAC, lighting systems, security systems for access control and threat response, fire alarm for safety coordination, elevators for traffic management, utility metering for real-time consumption monitoring. Everything comes together in one platform. And so I hit upon a couple of things there, but here's one of the interesting ones, and it's a building that we're going to be looking at the next year. And that's a building that wants to, as part of the security system, integrate drones as part of their security system. They want that to show up in the building automation system. It's a brave new world out there. We want to look at weather data. We want to see the nearest airport. We want to gather forecast information from the weather station and from weather stations to tell us what's happening and what's going to happen. That'll tell us what we need to do for the building coming up in the future. We know it's going to get warmer. We know it's going to get colder. We can respond and make the building respond appropriately. Instead of waiting for the building to respond to that, have the occupants get hot or cold and then do some other things as a result of that. And as I said earlier, we're going to be connecting with drone security devices. That's a common security tool. And we expect that what we're going to be doing with that is we're going to be integrating some of that information with local law enforcement. So if something's happening on site that we're not satisfied with or we're not happy with, we're going to take the feedback from the drone and dump it over directly to local law enforcement. That has implications, privacy implications, and those are things that the owner is working through, things that we're working through with them and with local law enforcement. But it is something that's happening. It's just part of the real world. Performance validation for this kind of stuff for integration is pretty rigorous. We want these systems to operate in a fault-free manner for about 3 weeks without failure. And if they don't, if they do fail during that period, 3-week window starts again. And that 3-week window of fault-free operation is actually one of the final legs in acceptance of the project. And IT security is not a one-time checkbox. We're going to have ongoing internal, external security verification throughout the warranty period and beyond. There are two little things that you need to know about. One of them, you've heard about a major department store being held at ransom, and that's a few years ago. But more recently, another larger department store lost its cash register for about an hour, worldwide, lost them for about an hour, and that was a result of a hack. So, and that hack was a physical hack. A contractor was doing work in their data center, connected a computer into one of the local networks to do some service work, even though they weren't supposed to. And they had unknowingly had a virus on their machine, and that got into the server farm. So happens all the time. Next slide, basis of design. So basis of design translates the owner's project requirements into specific technical capabilities. And when we say this is advanced, graphics are very important. That's how people see, feel, and experience the automation system. And we're not looking for something with colored dots. The walk-by rule applies. Anytime I'm looking at a screen, I should be able to look at that screen and make sure that I understand whether or not I'm in trouble or not as I walk past the terminal. So that doesn't mean I have to go, oops, something's going on here. I need to sit down at the terminal and click through a batch of screens to figure out what's going on. Every screen that I'm looking at should tell me whether or not I have a problem just as I walk past it. That is a large responsibility, and it's a design requirement that the designer has to have input on and the owner has to have input on. So that means screen submittals are now going to be part of the submittal package. Fault detection and diagnostics goes well beyond just simple alarms. So a traditional system will tell you something's wrong. Fault detection diagnostic tells you the supplier temperature is higher than set point because the cooling valve is stuck at 40% open. And that suggests a failed actuator or a control signal problem. Here's the diagnostic steps to determine which one. So that brings us to one of the things that we talk about in terms of predictive fault detection diagnostics. Wouldn't it be nice if you could say, hey, you know what, I think your chiller is down about 10% in its charge. 10% down in chiller charge is 10% loss of capacity. It's also 10% more utility use. Or one of my favorite ones that we're seeing now a lot, PV panels catching on fire. There are ways to monitor the PV system that will tell you whether or not you're probably going to have a thermal event in the next few weeks. Sometimes if that thermal event happens a lot faster. Sometimes that information that you use that you're monitoring will give you some advance warning, and it's only a few minutes. But 95% of the time, it's going to tell you that you've got a problem and you've got a few weeks to deal with it. So those are things that are really important. Having a PV panel catch on fire is a very bad thing, especially if it's up on the roof of the building. Of course, feed-forward control. It's nice to know what's going on with weather conditions. When you look at a cooling load is comprised of an internal load, an external thermal load, an external solar load, and an external humidity load. And those external loads are all predictable. We can gather weather data from the local, from the local airport, and it'll give us some information about what's probably going to be happening in a few hours. And that will help us decide what we're going to do with temperature set points and things of that nature, as opposed to waiting until that causes an issue in the space or causes some load in the space to make changes to conditions there. And that's a fundamental difference in terms of what we're talking about in terms of control. PI response is a proportional integral response is something that's been around for probably about 80 years. Actually, it's closer to 90 now. But feed-forward control is something that says, hey, I'm not going to throw the football to where the person is. I'm going to throw the football to where they're going to be. And it uses information that applies to a load. And if you can look at that information and know it's going to affect the load, you can start making changes before the load is actually responding. And so your response will be lower and you'll have less overshoot and undershoot. And our data tells us that generally is worth somewhere between 5 to 10% of the total utility used for the central plant, just by knocking off overshoot and undershoot. Also makes the place a lot more comfortable. We really are very concerned about alarm management. It's very critical. We want to make sure that we have, if we have a power outage, as an example, we just want one alarm. We don't want to have an alarm from every device that got shut off. If we have a chiller plant that lost its chiller, it's okay to have one chiller alarm. It's not okay to have one chiller alarm and 40 air handling unit alarms to tell us that you've gone over temp. We already know that. Similarly, we want to have the system be smart enough to do some alarm escalation so that if the alarm goes out and it's not responded to, that it moves to somebody else and sends them a message, and so on elsewhere within the organization. Finally, video training is becoming a very important thing for our group now. And what we want there is we want to have a number of short videos accessible from the automation system. So if you want to know how an air handler works, there's a spot you can click on the air handler graphic, and a short graphic pops up, a short video pops up to explain how the air handler operates and how it's controlled. Same thing with a chill water valve, same thing with the boiler, same thing with the pump. And in that video, it talks about typical maintenance routines, might even talk about spare parts, some of the videos that we're looking at. Next slide, please. Early collaboration. We want to define success together. Real important in this case, for those of you in commissioning, if you've done this before, commissioning authority must be engaged early during design. So that's around the, 20-25% drawing preparation area or drawing preparation time. They're contracted generally. We like to see them contracted directly to the owner, and it gives them some independence, a little bit of authority. And we want to see them in design meetings. We want to talk to them about what our view is of the building, what our view is for its operation, things of that nature. And usually with owners, it's kind of tough to get an OPR and a BOD from them, owner's project requirements. And sometimes you have to work that with them so they understand what you're trying to get their goals and their wants and their needs out of this. And that process requires some experience in terms of usability and buildability and affordability and things like that. And that's where the commissioning people become very valuable. They're able to provide that sort of boots on the ground feedback to that process to get it cemented in the real world. Very important to have the designer and the commissioning authority have input into scheduling. Doesn't do anybody any favors if all of the important stuff in terms of getting the automation system running is squeezed into the last 2 weeks of the project. That's a recipe for failure, and you'll end up with something that's sort of average or less than average. And I would respectfully point out to everybody that if you rush that and you get average or less than average, producing something that's average, I don't know about you folks, but doing that scares the hell out of me. Average is not, that's not what we're here for. Now, it might sound a little bit like what we're going to do is we're going to beat up on the BMS contractor. We've already said that the designer is going to have to do his thing in a way that's a little bit different. No more canned programs, no more canned sequences. They got to pay attention to what the owner's doing. They got to listen to what the BMS contractor is providing them. And yeah, the BMS contractor is going to have to up their game as well. Can't always be same old. Can't grab the sequences from the last building they were working on and slam them in. It's not going to work. But if we can do that, they will get off the job quicker, sooner, with fewer construction issues, and the designer will have less issues as well. So if you pay attention to this and make sure you're paying attention to the sequences and the build that you're working on, and you provide that, you'll get through commissioning quick and you'll be off the job and you'll make your money. As an aside, as an installer, a BMS installer for 15 years, that's how I made my money. Didn't make my money cutting corners. Made my money making sure that I met the requirements of the project. I finished it and I got off on time. Next slide. Performance-based flexibility. Design approach has got some competing objectives. You want to maintain fair competition, ensure quality, you want to enable innovation, you've got to do some future-proofing, and you got to adapt to vendor strengths. Nothing is more frustrating for an owner to have a design go out, have a contractor selected, and find out that the contractor has a feature that is not in the design. That's the first oops. Then the second oops is, well, there's a feature that's not in the design, and it works really well, but it's not in the design, so we're not going to do it on this job. As an owner, I look at that, and my first question is, what's going on here? So you've got to assess capabilities of multiple vendors, and if the vendor has got something that you didn't know about, and you got to change the design slightly, it's no big deal. Change the design. It's not something that you have to whip out a Gutenberg press to reintroduce into the world. It's just electrons and stuff like that. So you can change the design and you can use the tools that are available to you. They may have advanced fault detection, which is, you'll see from one vendor to another is a little bit different. Things that are coming up that you know about, and that's okay. And so then you can incorporate it, and it might well be a change, and the vendor might want to get paid for that, and you'll have to make a value judgment, but you're going to have to assess that and see whether or not it's worth it. So you're going to find that going through this process, that once you've selected a vendor, you may, in the design process, you may be going back to make some changes to the design or sequence to suit that specific vendor's capabilities. That is always going to be the case. You're going to have a vendor that sometimes is good at some things and better at others, and maybe not so good at a few things. You're going to have to make those changes to suit what that vendor can produce. And it might sound that means your design is in a state of flux. It's going to change from one project to another. And I would say, well, welcome to the new millennium. They have your documents are absolutely going to be changing. Owners, users, contractors, the market, and the rest of the world would deal with change every day. And so the idea of static control sequences that don't change for several years resides in last year's dumpster. So now we're going to look at a case study, which is the next slide. This is a static design. One that we walked into, that I walked into as a outside consultant. Static design that had been used by the designer for several projects for several years. The sequences were the same, and in fact, there was a problem because they selected a chiller that was not capable of operating at lower capacities. It was a 1,000-ton chiller. They wanted to operate it, it'd be able to operate down to about 100 tons. And it's a falling film chiller. It could not operate at anything less than about 400 tons. And so we got involved because the chiller had surged out twice. And, our assessment of that was, it's going to surge out and it's going to continue to surge out until you remove that chiller from that part of the sequence, grab one of the other machines which has some capability to operate. It was not the other chillers were not mag-bearing machines, but they could operate down to 100 tons. And so we have one of those now running as a primary chiller. Just to give you come full circle with that, apart from losing a chiller and having to repair it a couple of times, which is $80,000 fix each time, that machine in a space of 7 years went from being what should have been a 7-year-old machine. Our assessment is that it's currently about a 25-year-old machine, and it's only got about 5 years worth of life left in it. So they're going to have to replace it, and it's going to be 10 years old when they replace it. And really, that machine should last about 25, 30 years. All because of the static sequence, static design and static sequence. Next slide. Looks like we're about on track. Installation requirements. Now, so installation quality is absolutely fundamental to system performance and reliability. You can put in all kinds of fancy algorithms, all kinds of sophisticated stuff, advanced software, but if the physical installation is poor, the system will never perform reliably. If the system installation is poor, the system will never perform reliably. Never. Let me walk you through some critical installation requirements that protect signal integrity and ensure safety and provide long-term reliability. Wire sizing is very important. When you're dealing with control signals, very important that you get the correct wire size. You'll see one here that says a control rate for 24 volts AC. It's very common with terminal boxes to have 24 volt power going from one terminal box to another in a daisy chain. You might put 6 boxes on there. Maybe even sometimes they'll put 8 on. And that's a problem. You've got to have you got to have wire size sufficiently large enough to handle that current load and not introduce a voltage drop. Wire gauge for communication circuits that affects impedance and capacitance, and that's also an important function. And if you're looking at longer communication runs, you have to make sure you understand what that wire gauge is. You don't use whatever is convenient on the back of your truck. You've got to calculate and specify wire sizes for each circuit type and application. Now, where does that calculation reside? Well, it's certainly got to show up in the BMS submittals, but when you provide that information on the BMS submittal, you need to talk about what that current draw is on that wire and show that you've done a wire size calculation. You can't simply say, here's the wire we have, this is the wire we use, this is the wire that's going to work. It doesn't. We're going to talk about that in a couple minutes. Shielded cable for all low voltage control and communication circuits is non-negotiable. It is absolutely a requirement for any analog input or output. It is a requirement for any communication wire. I can live with digital signals, on-off signals coming in as just straight wire, but I question why you would do that, why you would have shielded wire for part of your installation and not for another part. Question why you would do that. When you connect up to adjacent power conductors or VFDs, anything, your lighting ballast, any of that kind of stuff, you need to have that shielding. When you have that wire running in the ceiling next to a lighting circuit or lighting panels, LED lights are very prone to producing harmonic energy, and they'll induce that harmonic current into DC, into I/O points. So, analog or digital inputs and outputs. It'll introduce a current into there, which goes back to the panel and causes a problem for the panel itself. You get erratic sensor readings. You can have unreliable control, comm errors. You can actually have controllers that, or control panels that go into fault conditions and reset. Shield's got to be grounded at 1A only. That's at the panel. And there's a grounding bar requirement, which is an NFPA requirement that about 90% of the panels that I look at fail. There's a very strict NFPA requirement full of pictures and very, very detailed information about what that grounding bar is supposed to look like. And it's not a tech screw, let me tell you. When I see that, I kind of lose my mind a little bit. So you need to have a plenum-rated cable. Sometimes you need to do that because you're running in plenums. And there's a fire safety requirement for that. And we do want to look at making sure that you got that plenum-rated cable and you got correct wire types. There's routing issues that we're also concerned with, and maintaining a 12-inch separation between low voltage and line voltage is kind of important. And if they're going to cross, make sure it's at 90 degrees. Please don't tie wrap them together parallel to one another. Don't do that. You'll induce currents into them for sure. And we're going to talk about that in just a minute. One of the bad horror stories. Panel grounding is very important, and you can actually cause some problems for the controllers with poor panel grounding. The controllers will, you can reset a controller by putting about 20 volts DC onto the ground connection for the controller. That's true for any automation system, any controller. If I ever run into a problem with a controller that's not functioning the way I want to, I can grab a couple of batteries. I can give it a good little shot in the ground section. It'll reset the controller. Memory will get downloaded back to the machine and it'll start all over again. Common service trick. So if you don't have that system grounded properly, it's getting voltage on that ground all the time. And it might not be 20 volts, but it also might get to that point from time to time. So you need to have that grounding inside the panel set up correctly. When we do grounding testing, we actually use a stakeless ground. We test all the panels to see whether or not they're grounded correctly. Even though they may be installed correctly, you want to make sure that the wire actually goes somewhere, ground wire actually goes somewhere, and the ground connection is solid. Harmonic isolation for VFDs is very important, and not unusual for a VFD signal wire coming back to introduce voltages as high as 60 to 80 volts. That's common, very common. Not consistently for seconds, but it will introduce it enough, and it can burn out the input. It can also reset the controller, or just give you really errant readings. More often than not, it'll give you errant readings. Next on the list is controller resets. It'll cause the controller to reset, and every once in a while it'll burn out the input or the controller itself. And so that specification, the designer has to specify grounding. You got to specify NFPA requirements. It's got to show up in the submittal. Got to be caught. Got to make sure you're doing it right. Now we're going to talk about the next one. Next slide. Wiring disaster. So in this case, we had a site. I walked into a site that had terminal boxes that weren't communicating, controllers that were resetting regularly, and in some cases burning out. An automation system that was basically 4 years old, and during that period, from the owner communicated to us that they felt that during that 4-year period, it had worked for a total of about 5 weeks. What we found was that the 24-volt wiring to the thermostat, not the thermostat, to the terminal boxes, you have to, when you're wiring those in daisy chaining them together, the polarity has to be the same. You can't switch polarity on that 24-volt wire. Even though it's only 2 wires, you have to keep the polarity the same. If you don't, one of those controllers may relieve some energy to ground, and when it does that, it's going to relieve it to the power wiring side of the adjacent controller, and you'll lose that controller will take that power, and it'll relieve it onto the comm line, and the whole loop will go down. And it might go down for a little while, it might reset, it might not. So that was the whole building was doing that, and there was something like 400 terminal boxes in that building. So they never had any more than about 25% of the boxes running at any time. All of the VFDs in the building, of which there were something like 100, 105, I think. All of the VFDs were sending harmonic energy into the controllers, and that was causing controllers to reset, and in some cases burning them out. So those items are fairly easy to correct, but the other issue that was not easy to correct was almost all of the communication wiring and all of the I/O wiring was tie wrapped onto line voltage conduit. And so the whole installation, they were losing comm all the time. It was really a mess. For legal reasons, the owner obviously they were in some kind of dispute with the contractor, and so they decided that they were just going to replace the system and deal with the old contractor and all the legal issues separately. And so all of that wiring was abandoned. None of the control panels were reused. In fact, the boxes weren't even reused because they weren't grounded properly. And the input and output devices had to be discarded because we found that about half of them were ruined by having errant voltage applied to them. Very expensive installation for everybody. Next slide. So documentation and submittal requirements. It's not paperwork. It's just for paperwork's sake. You're not drilling holes in the sky on this one. You're actually providing verification, training, troubleshooting, putting wire tags on there, It's a document that helps your installer do their thing when they're putting wire in, so that they can wire tag everything properly. And that's how you start this off and start the installation off. It's the last chance the designer has to say, yes, this system is following what I expect to see, and it's going to enable the things that we're talking about doing. It's the last chance, the last little bit of chance you have to say, okay, this looks like a good deal. Now, when we get submittals, we're looking for graphic submittals, and we sometimes will ask for live simulation prior to the installation. Not always, but we'll certainly ask for the graphics. We want to see what the graphics look like for sure. Live simulations are sometimes difficult to do, and they can be kind of limited in what you can do and what you can't do, and you can wind up having discussions about what the simulation is and the limitations of that are. So sometimes we'll do it when we're looking at complex systems. We might ask to simulate a system, but not the whole building. We will want to look at the graphic and look at navigation points and what you click on and where that goes and things of that nature. And that helps the end user. That helps the end user, and it also helps the contractor because the graphic is now complete. It's ready to go. They're not going to be making adjustments to the graphic afterwards. Wire tagging, we talked about that. Going to continue to talk about that. There's a point-to-point process, checkout process that you have to go through. And if the wire tagging is present, you can do the point-to-point checkout, and you can do all of the associated tests with wire tagging, and you can document it if those wires are tagged. If they aren't tagged, you're not really going to be able to do any testing accurately or properly. Tagging is important. Also, that helps with calibration. You know which wire it is. You know you've tested the wire's okay, the end point-to-point is done, and you know it's continuous. You don't have any skin wire or anything like that. So when you go do calibration, it makes calibration a lot easier. There is a business points list that I want to talk about for just a second. It kind of defines, point lists define how often data is collected, how long it's retained, how long trends are for. Are they for 30 days? And what happens after 30 days? Where does that data go? Need for analytics and optimization. You need that information for that long term. And I will tell you that in other parts of the world, in some parts of the world, that historical data actually does not reside inside the building. I disagree with that. It resides somewhere else outside of the building. And in fact, some of the optimization routines reside outside the building. So when the owner goes to sell the building, or anything happens with the building, one of the things that they have to do is say, hey, can I have my data? Can I have my optimization routines that you've been working on, that I've been paying you for? And the answer that they very often get is no, you may not. Or if you want that, we're going to turn it over to you in printed form. You can have all 3,000 pages of it, not turned over electronically. And so this for those of you that have been through this before, this business of that business of sort of hanging on to data and having an outside agency own part of your building sounds an awful lot like what building automation systems used to be like back in the 80s. And owners don't like that very much. And I would caution you against doing that kind of stuff. It's not a very good long-term plan. From a business point of view, I think it's going to hurt if you do that. Next slide, please. Should be operator readiness. So best system in the world is useless if the operators can't use the system. So you're dealing with a mixed capability workforce. Some operators have years of experience with advanced automation systems. Others are newer. System must work for both groups. And not unusual these days, very, very common in fact, to have people involved with operating a building that may have grown up with a different language other than English. And so while they are able to work in English and understand most of it, it's not germane, it's not native to their thinking. And so when something happens, that like an emergency or something like that, their brain internally is going to respond, and they're going to think in a different language. They're not going to reflexively think in English. So you have to keep that in mind when you're developing graphics and you're developing maintenance routines. You have to understand that a number of different people are going to look at this, and they're going to try to make this work the best way they know how. And it's going to be different from what you see. And now I'm going to ask everybody to do a little test. And I'm just going to ask you to take your hand and hold it up in front of you and tell me what you see. And you're going to look at me and you're going to say, what is the matter with this guy? I see my hand. And yeah, you do. You see the front of your hand. You don't see the back of your hand. The back of your hand looks way different from the front. And that's what we're dealing with when we're producing inputs and outputs on a screen. We need to be able to show people some things that they need to understand, but we need to do it in a manner that they can understand, not that we can understand, that they can understand. Video training, very important. It's a game changer. People can look at that video, and they may look at it 2 or 3 times before the point gets across about what they're supposed to do. We view these videos as key, and we think that videos that are between 2 to 5 minutes, 5 minutes at the most, that talk about components and talk about systems are very, very handy for people. They can go through that and they can understand what's going on, and they've got a bunch of other things that they have to do. So this will be a way for them to reacquaint themselves real quickly with what you're doing. Video training and intuitive troubleshooting. So we do want to have some way for fault detection and troubleshooting guides and workflows to be part of the automation system. And so that is a key component in how the building is supposed to operate. And we're going to talk a little bit right now about value. So if you're installing these things, you're thinking, wow, this guy's asking for a lot. What's he willing to pay for? I'm an owner. So let me tell you that if you're going to produce a product that is average, and it's something that comes out of the 1990s, and it doesn't have very good fault detection, and that's the best you can do, and the graphic looks kind of cheesy, probably fail a Bugs Bunny cartoon test, and all of that, no, I'm not willing to pay for an awful lot of money for that. That's less than a toy. It's not even a useful tool. But if you're going to produce something that helps me run the building, and it's got a graphic package that is useful, fault detection that's very good, easy to understand, it's got videos in it, I'm going to look at that and say, yeah, I'm willing to pay a premium for that because it's a tool that I can use. If I've got if I'm a building owner, and if you think about me like I'm a carpenter and I've got to cut, 300 2x4s in the next 4 hours, I prefer to use a skill saw instead of a handsaw. So I'm looking for a skill saw to operate my building. I'm looking for a tool that's useful. So next slide, third-party integration, testing and validation. So testing and validation starts early, back in the design phase. And you're involved, if you're doing this properly and you've been engaged properly, you're involved in submittal review, and you're doing third-party integration. You're looking at fire alarm systems, security systems, lighting systems, and you're seeing these things one at a time as they're implemented, turned on, and integrated. And they get separate dedicated protocols. They're tested separately. The fire alarm system is tested separately, and we see the integration from that as well. Same thing with lighting. Same thing with security. And you want to test graphics and sequences as they're being installed, so you can see how it's being installed. And if you're doing this as it's being installed and you're part of the process, you don't have this huge process at the end to do commissioning. Generally, by the time someone has finished the installation and they've done all of their work, you might have another 2 or 3 days or at most a week, and you're done. You've already looked at all the things they're looking at, and you're okay with how it works. You will want to look at shoulder season operations for some of these systems, and you will want to do some things that are sort of ongoing, particularly with video and security systems. They have a tendency to operate a little differently when the weather goes haywire on you. So you may want to come back and look at them, and also some of the larger mechanical systems, chillers, boilers, things like that. Once they've been in use for a little while, sometimes their integration goes a little haywire. And the commissioning process, next slide, slide 12, coming up. So pretty important to get this done early, get the OPR and BOD, go through the process of reviews and sequences and submittal review. And again, same sort of thing. We're going to go through this and make sure that we're doing our testing while the contractor is doing theirs, so that we're not impeding the process of the job, and we're watching what they're doing, seeing if they're doing the same tests we are. And at the end of it, we have a little bit of a period where we say, hey, it's got to operate 3 weeks with fault-free operation. I want to see the system run without internal faults. If it does, away you go. There's some post-construction work to do in there as well. And I will tell you, if you're involved with the process for the case study, which is the next slide, post-construction commissioning, it usually results in rework. If you show up and the first time you show up is when the installation is just finishing off, you're going to be producing a lot of rework. The stuff that hasn't been done, hasn't met requirements, and you're gonna generally cause some issues because there may be problems with the design as well. And so you're going to be going back and forth with that, trying to deal with design issues. And it just is a real pain if you're doing commissioning during that period. That's the only time you're doing it. And really, the project is going to end up being kind of average. You're not going to be able to produce something that's world-class commissioning it that way. Next slide. Post-occupancy and warranty performance. We do have, during the warranty period, we do have some commissioning requirements. We want to see how the system runs in different seasons. And we want to see if the building analytics are working. Are they being reviewed? Are we achieving energy reduction targets? Is the system being operated properly? And are the videos okay? Do we need to make some changes to that? And that sounds a little bit like for the contractor, you're going like, hey, this guy's going to jack me up for warranty issues. Not really. If you got to change a video, or if you've got to change a graphic that's already been approved, you're going to have to come back in, and someone's going to have to pay you. Everybody did their best effort, and the best effort didn't meet the requirement of the building. So I look at that as an owner and say, well, you know what? I think we got to pay you. We need it to work properly, and we took our best shot at it, and our best shot didn't quite work. So let's give it another shot. And also during the warranty period, you may find that the vendor comes up with a different idea or a different product, and you might look at it and go, hey, let's incorporate that in the project. Not the end of the world. Team success. Next slide. So 4 little things here. Designers got a role. Contractors got a role. You can see those on there. And the commissioning agent's got a role. So does the owner. And you'll notice on there that one of the things that's common to all of them is adaptability. There are going to be things that you change. There are going to be things that change as part of the project. You're going to have equipment that shows up that's different from what you thought. And you may have to make choices for different equipment to meet scheduling needs. And in fact, you may also have, the owner may have some changes in the building. They may say, hey, I want to change the space use, or I want to do different sorts of things. And that's going to require some adaptability on everybody's part. And you're going to have to work together to figure it out. If you do that, everybody's going to be successful. Make some money, finish on time, and go home and make a beer commercial. And so that is the extent of my presentation. I am going to include, when I send this through, I am going to send the file through to Abraxas. I'm going to include some fault detection calculations for you. These are items that we use as part of our implementation process, fault detection diagnostics and calculations for motors and VFDs and chillers and things like that, air handling units. And so we'll include that, and I'll include a couple other, some other little things that we do when we're doing our installation that make life a little easier. There's Alex.
Okay. This is John. So I'm going to ask a question or two. Here's one.
Sure.
I find that the OPR is lacking on many of the projects I work on. Do you recommend any resources to help explain and produce an effective OPR?
Yeah, so we're going to, there's a couple of neat little tricks. One is sometimes I'll walk into a room like this with an owner, and I'll throw 100 pennies on the table, and I'll tell him he's got to split up the pennies, telling me what's important and what's not. And if he can't, then when he's there, I'm going to split it up for him, and ask him if that's okay. And
have you really done that? Have you really thrown the pennies?
Oh yeah.
You
Yeah.
have. Crazy.
Yeah.
Okay.
Yeah. Now there is an updated version of that, and it's a way of doing evaluations and of what's important and what's not important, and it looks at it's an Excel spreadsheet, and I'll send that along too, and it makes you look at different parts of what you're thinking about, and is one part more important than the other, and how much more important is it? What's the outcome of that? And so yeah, so it is an issue, and I will tell you that it's not unusual for an OPR statement to change partway through the project when an owner looks at it and goes, I never really thought that was kind of what I wanted. Okay, you change your mind a little bit. You're an owner, you can do that. Well, you're also a human being, so you know.
You're gonna give this talk at let's see, AEE World in, gosh, when is it? In about a month. Yeah, it's
Yep.
AEE World, for those of you who don't know, or it's September 16th through 18th, and it's in Orlando, Florida. And you're going to speak for an hour on this. Oh, you just did speak for an hour. Now, are you going to give more examples? Are you going to do anything different in that presentation?
So based on so you understand, and this is part of how we do things. Anytime I give a presentation and someone asks me a question, it tells me that I need to change my presentation. So take a guess what I'm going to be putting in my presentation at AEE.
About OPRs that are lacking.
Yeah, you got it. You gotcha. You gotcha. So and we're going to go through a process. How you do that? A couple of ways to do that, and talk about a little tool.
Okay. To everyone, we'd love to see you in Orlando. I mean, I know a lot of you are on the other side of the world, and a lot of you have companies that won't send you, but if you can convince them to send you, please come. If you've been, attending a lot of these webinars, come find me. I'm going to be in the Hillman booth. I'll be wandering around, or actually mostly in the booth. So, come and shake my hand. Just say, listen, I've been listening to your webinars. It's nice to get a pat on the back once in a while. So please come see me. I don't have any more questions. That's the only one I've got. This is more technical than I'm used to. I'm used to more broader things, and I'm not involved in installation. So I really don't have much that I could really say, because I don't know anything about this stuff. So.
Right. So digest. I'm going to send some material through to Abraxas, and for those of you that are online, if you're going to look through that material, or if you have questions, you can get a hold of me at JLL. Happy to help. This is a new way of going through this process, and I can tell you there was a learning curve for our group and for our company to do this. But now that we're doing it, It is a difference between walking down the street or riding a rocket ship. And so if you're doing it right, it works like a hot damn.
Yeah. So I got another question. I found one. Saka is saying, I live in Ghana and I want to find out how I can develop my competence practically in the BAS.
One of the other documents that we're developing is how to write a sequence, which is a lost art, and it's a process that we're developing right now. And I would expect I'm going to slam that onto the Abraxas site as well. How to write a sequence of operation, and so that's one thing that I would start doing, is having an idea about how you're going to write that sequence, and what you have to look for and what you expect as an outcome. I would go about that one way, and then one of the other ways is looking at field work associated with it. And I can tell you that Schneider actually has some pretty good online courses for this kind of stuff, for installation, BMS installations, control panel installations, and connecting up to UPSs and generators and things like that. If they were pretty good set of classes for that.
One thing I would suggest, I mean, this is your presentation and not mine. I just always like exciting things because I want to be entertained. And I think, my experience, which you've seen too, is that BMS is just a bigger tool. Like I said, it's it's like a sledgehammer, and guys can do a lot of damage with the BAS. It's like someone's cold, or no, they're too warm in one room, and so then they change the chill water supply temperature, just like, oh yeah, that's what I always do, and I always take care of everything, and then meanwhile they're wasting thousands of dollars because they do these stupid things, and I think that's really important, the whole operator training, and the fact that they need to understand the monetary consequences of bad decision making when running these systems, and I think a lot of guys just don't give it a thought. And that's, I think, part of the training that's missing. It's like, look, you do this. This is what it's costing the building.
Yeah, it's we expect to have, what I expect to have is a running cost of operations while you're looking at the automation system. It's sitting there on all of the screens that you look at, every last one of them. And so that's my expectation. It's this much per ton. And if you make that, certainly in the chiller plant, or a boiler plant, if you make a change there, it's easy enough to say, hey, if you do that, what's the expectation? What is it? If I make this change, what's it going to do to the cost? And certainly it's going to show up. You made that change, and the cost is going to show up. It's a trended point. Why did the cost go up? Well, it went up because somebody changed the set point. It's a step further, which we haven't looked at yet, which is, hey, if I make the set point change, how much is that going to affect our operation?
So someone's going to do this, Duane, and that is an AI interface where you just say, hey, dude, it's too cold in room 39, or maybe you don't even need to say that. Can you just change the chill water set point down lower? And then the AI should respond, why do you want to do that? Oh, because it's too cold in room whatever. Oh, have you tried doing this instead? This might work better. That's what's coming, and that's what really we need, rather than having these guys have to understand, oh, this is expensive and not. AI can do that and just, tell us that. It's like, look, why are you doing this? This is probably better. Why is it better? Well, because this is going to cost you this much, and this will only cost you this much, right?
Right. Yeah, and that is one issue that makes it important. I'll tell you another one. I'm going to go work in a building in about 2 weeks that somebody made a mistake, and they made a mistake in operations, and it basically blew up $1 million chiller. That chiller's done.
I love those stories.
It's not,
those stories.
Yeah, and so no you know, no safeguard except for common sense. And so you would look at that and say, okay, well, the guy didn't show any common sense. Yeah, but it was still allowed for him to do it. You know,
It should be idiot proof.
and
Yes.
and right, and there was no question, there was nothing, no consequence, no choice, no what if I do this, what if I do that, and so I would agree with you, John. You know, it's something that, and a short story. So I did I commissioned a gas plant once, and we as we were going through training, operator training, we kept saying this was in Siberia. And we kept saying to these people, hey, if you do this, we're going to have an explosion. If you do that, you're going to have an explosion or a fire or something like that. And after a little while, we realized these people had never seen a large explosion or a large fire. The largest fire they'd ever seen was the one they did when they were trying to, you know, roast an ox or something, right?
Oh,
and so what we did was we got some heavy oil in a depression in the ground, and then we bled a little gas underneath. And we stood back a little ways with them and said, okay, we're going to make a big explosion so you see what a big fire looks like. And we tossed a flare into it. Well, it was a little bigger than what we thought. And it was quite an explosion. There was quite a flame. And, you know, didn't hurt anybody, but there was a loud noise. And they actually thought that we broke the world. They ran out of town, because they had never seen it before and they had no exposure to it. So when you tell someone that you can't do this because it would be really bad, well, what's the reference for really bad? They don't.
Yeah, exactly.
They don't have the same reference we do. Yeah, they just don't. So
right.
You know, you got it. I think it's something where the industry has to go. You just have to do it.
So I got another question for you. So have you seen any BAS systems where people are just saying, can you just increase can you increase the outside air of this room? It's stuffy in there. A guy just types that in, it goes and does it. Have you seen that? Does that exist?
We don't have anything that responds verbally, but we do have systems installed that ask that you can say, hey, I have a problem with this room. I want to. It seems stuffy, and it gives you some choices.
Okay, but it's not like a ChatGPT thing yet.
Not yet, no. So
it's coming.
We don't have that
That's
capability yet.
So I was talking to Gabriel. You know, we have this software. It's an option C M&V software. I'm not trying to sell it, so don't worry. But we're talking about implementing that, where people say, hey, can you add 3 meters? Oh yeah, where do you want them? Under what area? We'll put them under this area. Oh, okay. And then what do you want to call it? What's the meter numbers? Type them in, you know, that kind of stuff. And so where it's just a dialogue and it will create things. People are doing this now with building modeling. And so it's coming. It's coming to BAS. And that will resolve a lot of problems with guys making stupid decisions. It really should.
Yeah. I will tell you something about this that makes me a little bit nervous. I know the people who personally who have made ChatGPT. They're great guys. I love to play poker with them. But one of them has a little problem trying to figure out that he should wear the same color socks every day.
So what? I'm sure Einstein had that same problem.
Right. And he solved it by wearing the same outfit every day forever. And I would just caution everybody when we're looking through this that some of the individuals involved in creating logic behind ChatGPT don't think the way other people do, and if humanity was a rainbow, they are way out in the ultraviolet section. And so you got to kind of keep that in mind when you're getting a product from them. You got to do some testing, which is what we're at right now with a lot of our AI. We're doing that kind of, you know, are you part of the human race kind of testing? Or should you be alone, or you know, should you be let out of your house here in the morning, or what? I don't know. So those kind of tests, it's not common. You don't get a lot of it, But every once in a while, you'll see, very recently, you see some AI tools that have gone loose on their own and
Oh, yeah,
decided for various reasons to hack into other systems, right?
sure.
So
Sure.
that
And
that
that's-
didn't happen because somebody thought of it. That happened because that was a tendency drilled in or programmed in by the people who made it.
Yeah,
So
same with Skynet. That didn't happen by accident either. I mean, or
right,
Skynet's a similar deal, right? So,
right,
right.
right.
Why are some VMS owners unwilling to give the owner SEO? What's SEO? I don't understand what that means. Maddening. I don't know
Sequence
what
of
that.
operation.
The sequences. Yeah, it's terrible. Oh, it's awful. Okay, that's all I got. Everyone, thanks for coming, and we'll hopefully talk to you next month. We'll let you know via email and or LinkedIn post if we're going to be here. Take care, everyone. Bye.